Well, hello there again. We're going to talk about power. Power is the next component. And the main reason we have power is, let's say there was 2 students in class, and I was going to pay them to dig a ditch. One student wanted to get done real fast, and he dug his 1 meter wide ditch, 1 meter deep, that was 10 meters long, in an hour. Another student dug the exact same ditch, but it took him 5 hours to get it done. Who did the most work? Well, as we look at work does not have a component of time. It does not have time in it. So how do we determine what do we do with this when someone does something a lot faster or slower? That's where power comes in. Power is important to us because now it takes that time component and includes it. It allows us to compare by using time. Rate at which work is done is what power is. It's the rate meaning there's going to be a division. We're going to be dividing by time. Typically, whenever you see rate, hopefully you guys have realized you're going to be dividing by time. Most often. And in this case, it means we're going to be taking work and dividing it by time. The rate at which work is done. The units are going to be in watts. Well, let's look at our practice problem here. How much power must a motor have to operate a pump that raises 1,500 kilograms of water every minute a distance of 12 meters? Some pumps are going to have more power, means they'd be able to lift more than 1,500 kilograms of water. Some are going to have less power, which means they'd lift less than 1,500 kilograms of water. Not all pumps are rated the same. So, to do this then, kind of hit the wrong button here, I don't know how I did that, but we're back. I'm going to simply say, well, that's what I know here. My mass is 1,500 kilograms. My distance is 12 meters. And the time, as most of you have probably realized, if it's 1 minute, that means it's 60 seconds. Well, to find the power, I need work divided by time. I don't really have a work here. But I can go back and find my force by using the weight of the water. And that would be the mass of the water times gravity. So that right there would be 1,500 times 9.8. And that turns out to be 14,700 newtons. Now I have enough information to find power because work is also force times distance. So our power equation can be also written as, instead of putting work on top, we can just say force times distance over time. Well, power then here is 14,700 times 12 meters divided by 60. And what that turns out to be is this is a pump that would be rated at 2,940 watts. What I want you guys to do is I'm going to pause it. You guys, and I'm going to be right back, but you guys go ahead and pause it and see if you can't answer the bottom problem. Alright, on the bottom problem here, again, they're giving us a mass of 30 kilograms. They're giving me a distance of 25 meters and a time of 30 seconds. Well, this falls right into the exact same situation as the top one, where I'm going to have to find out the force, or what is the weight of this 30 kilogram child. And that's going to be 30 times 9.8, which turns out to be 294. So if I want to find the power, I can take 294, because that's the force, times the distance of 25 meters, divided by 30 seconds. And as you can imagine, I'm punching it into my calculator right now. And that power ends up being 245 watts. So hopefully at this point now you have a much better understanding of work and a much better understanding of power. There will be a quiz over this again tomorrow. Good luck.